Okay, I'm going to convert the notation here because, as I said, we got this uncomfortable idea, the situation where that almost looks like an x and a y derivative, right? Okay? So we kind of don't want to use that notation, and we get around that by just saying, okay, instead of using fx and fy to indicate x and y components, which makes perfectly good sense if you just keep track of the context and don't confuse that with x and y derivatives. But if you're a formula memorizer, you would, right? And everybody's a formula memorizer. Everybody memorizes formulas, okay? Just trying to get you away from dependence. I'm going to use P and Q, okay? So now, and this is, of course, f of xy, p of xy, and a q of xy. Or xyz if you're working in 3 dimensions or whatever, okay? So, we have this notation, so it's just px prime plus q y prime, right? Which can be written as the integral of p dx plus q dy. Since x prime dt, looking for a different color, but by the chain rule, or just the differential, so you see we can take our x prime dt and give us a dx, and we can do the same thing for y prime dt to give us a dy, right? So we can have this expression for the integral. This is a very common expression. Okay? Now, we've spent a lot of time on this. I'm going to leave you to figure out why. But if we want to do the integral of the normal component, now let's make sure I've got this right. And I'm stupid right now, so I'm going to verify that that's correct. Okay, because what's perpendicular to pi plus qj? Negative reciprocal slope, negative qi plus pj. Sorry, that's not exactly how, I mean, that is true, right? But it really comes from the fact that you do the negative reciprocal slope. Negative reciprocal slope of this would give you this, right? So that's going to be normal. Okay?
So you want it in the same plane rather than like the z component that's normal?
Yeah, well, right now we're in the plane. Okay? If you go into space, then you gotta do a little more calculation. Let's get the idea first. Okay? Now let me make sure that notation's right, because I'm actually gonna cheat and take a look. Because the question is, this should be an outward unit normal, okay? Well, is that gonna be outward? Because you got the curvature to take account of, right? And it's early. I don't want to do that in my head and leave you with a wrong idea, okay? I could have the signs wrong there. And I don't want to stand here and ponder it because I still might get it wrong, okay?